Hi, students. How are you?
Afternoon, sir. I'm good.
All right. Anybody has difficulties logging on for the class?
Repeat, sir.
Doubting said she'd be
Any difficulties at all logging on to the class?
Issues.
Sorry, say it again. Somebody was saying something?
I'm saying Doubting said she'd be late because she's having Wi-Fi issues because of the rain.
Oh, okay. All right, no problem.
One thing, sir, any information
Regarding the selection of geology?
sir, any information regarding the geology course on area and process?
Yeah, man, I soon update you.
Okay, sir. Thank you.
Mm-hmm. All right, so I'm having difficulties getting onto my laptop. I normally give you guys a 15 minutes, lag time to get in. I know some of you are still in commute. So I have 2 minutes left out of that 15 minutes. Let me see if I can doctor my system in the meantime. I really hope you guys come for conversations, because we are about to have some serious conversations. Give me half a second, please, guys. Soon come. All right. Finally in. Let me disconnect this one here. All right, give me half a second, please. All right. Back with you. How are you doing today? Hello? Anybody hearing me?
Sorry, sound a bit low.
I sound a bit low. All right, hold on. Thanks for that feedback. Hold on. Almost all now.
A bit better.
All right, good. Thanks, sir. Okay, great. Um, so Paz, tell me, how you do?
I'm good, sir. I'm ready for class.
You ready for class? Love the spirit. Venika, how you do? Asia, how you do?
So I'm still at work, not feeling so good, but keep
Oh, no.
on, you know, going through, yes.
Oh no. Osh, 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 osh. This too shall pass, and you know, we just have to be very careful with the, especially this climate. I know the semester ended, well, you just had a 1 week break from exams that ended the 3rd of when? The 3rd of July? The 3rd of June, sorry. And then you had 1 week break, and then bam, summer class begins. So we just have to really push ourselves through it. You two, I mean, I know my lecturers are in a bind, so am I, because the semester has started and we are mopping up the marking process. So it is that you can get your grades, you know, to move into the semester. So I know it is rough, but we're going to persevere. I know it is rough, but we're going to persevere. We're going to push through. All right. Trusting that you feel a little bit better though. Hi, Carlo. How are you doing? Karel, Davia, how are you doing? Michael, good evening. Alexia, what must stop the teacher night time?
I'm good, sir. I'm good.
Nice,
Good, sir.
nice. Good. So your teacher gets energy when the class speaks to him. And I am looking forward to that energy. All right. So I sent you some notes. I tried, I know I have the recording to send off to you. I'm trying to do a whole lot of prerequisite. Benika, let me talk about that now. So I sent a message regarding the geology. It's been somebody speaking? Oh, sorry. Hold on for me, guys. Hold on for me. Sir, yes, sir. How you do? All right, so I have not yet gotten, let me just check to see. I've not yet gotten a response, but hopefully before, all right, hold on. Something came in. No. All right. Hopefully before the end of the class, I should have something to say to you. All right, so what I did, however, though, is to send off the course outline, so it is that you can have a look at it. And I also sent you, as promised, the notes that I was making reference from. I hope you guys got an opportunity to just glance through, just to read through again. Remember, what I'm giving you is not anything that is exclusive, meaning that it's only this alone you're going to use to prepare for your exam. No, you're going to be reading. You're going to be reading widely. You're going to be, and when I say widely, if I talk about catastrophism, for argument's sake, and I present something to you in class about catastrophism, and I present my understanding of catastrophism to you. I would therefore expect of you to go and research on your own, or just to read, type it in Google, and to read to solidify your understanding of catastrophism, for argument's sake, right? So what I'm giving you, I don't want you to just hold that alone and say, okay, this is the gospel that you're supposed to be moving with. I want you to be able to read around it, and then you can come and say, boy, so say, I learned a little bit more, and that is the idea. My aim is to entice you to go and read the information and to get more than what it is that I am presenting in class. All right. So last time, Kylo, I didn't see you last class, but I'm happy that you are here tonight. Last time around, I shared this document, and all of you, those of you in the group, I'm interested that all of you are in the WhatsApp group, would have had access to this document that I'm trying to share, that won't share. Are you seeing anything that says, that indicates that I'm trying to share something?
Yes, sir.
Yes,
Okay.
sir.
All right, cool. When it comes up, just tell me, please, because I'm not seeing any indication on my system at all. Right, so we need to look at I need to spend a little bit more time on the scientific approach. And outside of that, now we need to look at some of the issues. So I placed a few issues, about 4 issues, A to D. And the syllabus asks us to talk about any 3 of the issues, right? There are times you may be asked to write about one of those issues that affect geology. And we will get into those. Hopefully, I should be able to even touch one of them tonight. Oh, Lord, what is that mean? Are you seeing the document? No?
Part of it.
Part of it. Move the cursor along the screen.
All right, it says that I'm sharing. Okay, I'm seeing a piece of it that is coming up. Can you see that I'm moving it? Let me just, okay, there you go. All right, now I'm there.
You're seeing it now.
Yes, we're seeing it now.
Great. So we went through all of that as a precursor to our lesson last time, and I really want you to just, as I said before, use it as reference. I don't want to just come to class and just present, we call it now, oh Lord, a PowerPoint and give to you. No, I want to give you a little bit more, just a little thing so you can read through, so that if you can have a reference point from which to go. And if you notice what I'm doing here, I've started 1.0, what is geology? So I'm going through the curriculum, and I expect you to do that. Now, here's the plan. You all can get A's for this course, Easy, easy. So what I'm going through is 1.0, and then you hear me say 2.0, the scientific method. So I'm extracting the information from the curriculum verbatim, and then I'm preparing some stuff for you. If I were in the first, we call it the face-to-face class, I would maybe dictate notes and give to you, but this is big school, all right? So because we're doing the online, I have to go and find online stuff that I can just present to you, all right? So I want to spend some time today on the scientific method, and then I can look back at and this is 3.0, I think Unit 1 has 3, 4, 5 or 6 areas to look at, and I'm at the 3rd one, so to speak. And then we're going to talk about some of these issues. But as I said before, it's not exhaustive, right? You need to do some stuff on your own. And I will know, based on my conversations and based on my testing, formative and summative assessments, whether or not you guys are reading and reading widely. All right, so let us talk about the scientific method. So I did mention that last time that, I will make reference to biology. I'll make reference to physics, I'll make reference to geography, I'll make reference to chemistry, I'll make reference to mathematics. I will also make reference to information technology. You notice what I've called just now? All science courses. All science courses. I'll also make reference to English language, because how it is that we communicate our ideas will be very important. The geologist has to write, has to make notes, is very observant, because these are the information garnered will form the basis of a report. And these reports are there for many years. that will stay in place for many years, and people will come and build upon this report. So I may say to you, funny story, where I was teaching on Monday, someone was around and heard me speaking to you about the Monique Lake. And was it yesterday, I think? The person was going through a textbook and saw where they had the Monique Lake as one of those areas that, you know, cause a lot of, pretty much the same thing that I was talking to you about. And I said, hey, see here, this is what you were talking in class the other night. See right here, so. And then I went and looked at the article and said, yup, real talk, right? So what was so funny about the picture though that I saw in the text, the picture, the water in the lake covered the house to about 3/4 way from, of course, has to be from the ground level to the window. So if you look at a standard window, say, I don't know, maybe a standard window is what, 24 inches, I don't know, 24 by 30 or 30 by 30. Anyhow, just to guesstimate, and this is one of the things, again, one of the issues in geology. Let me just point it out. One of the issues in geology is talk about scale. Yeah, number 2 here, talk about scale. That's one of the issues in geology. That oftentimes when we are in the field and we're taking a photograph, we put a pen by whatever we are taking, so it is that we can scale what it is. We may put a coin, we may put a dollar bill, we may put, if we're in the field, we may say what do you call it?
Ruler.
A ruler or a Pepsi cover, because all these things are standard that you can find one of those water cover, the WATA cover. You may see that you just put it along the field, the exposure, and take it, because you may not carry home that water cover, but if you come back to Kingston for argument's sake, and you pick up a water cover, the water covers are the same. So you are able to have some sort of scale for what is happening. So scaling is very important. So I am here telling you now, if you're using the window as a standard 24 by 24 or 30 by 24, the water level covered about 3/4 of the window. And I'm saying, so when I saw it, I immediately went to the window and I said, well, you know, windows are relative, because you can have a window from ground level all the way up to ceiling. So let me just use what it is that I have. And when I stood up by my window and look up, I was like, oh crap. It means then that if I were in that particular house, the water would have covered me. And I was like, crap. Just imagine you sleeping and there's a flood and the sleep's sweet and you're not paying no mind. And then after that, now when the water touches your nose and you're ready and you stand up, you're in neck high water. People can panic because they didn't expect it. It just come on sudden. And you can't run out a door, because you run outside, what is going to happen? You're going to be in deeper waters, right? So it is a catastrophic event that, you know, you have to be very careful and be very mindful about. All right. So just to say to you, you know, what that is. Okay. So when we look at the scientific approach or the scientific method, there are several things that we need to look at. We need to, one, make an observation. Yes, sir. You just spoke about that a while ago. An observation about the level of water in the place. We're going to ask questions. We need to question ourselves. You know, I keep saying, if Michael and I have a disagreement, and to the point where I'm saying, "Ima, come class and not talk to teacher tonight because teacher did something wrong." Michael, are you there? Sir, I'm here. And he said, no, but Michael don't sound how Michael's supposed to sound. And then said, when you come to Michael, sir, I will send you a WhatsApp message. So, you know, so Michael vexed you because you never mark in paper properly. I said, oh, so that's the reason. Ask a question. It is very important that you ask. No, Michael's supposed to come and say, sir, why did I die? Ask a question. It's very important for you to question. And as geologists, environmentalists, your responsibility is to ask questions, put things into perspective. And then you're going to form a hypothesis. Okay, as so Mr. Sean Mark, him don't want you to give him information verbatim from the internet. What he want you to do is to go to the internet read the information that is there and put it in your words so he knows that you understand the information that you're getting. All right? And then you're going to be making a prediction, say, based on what we do right this, so this is going to happen, And then even test the prediction. You know what? We're going to wait until the next rainy season to see if my hypothesis, which is a guess, is going to happen. Right? What is this guess? A geologist has many stories to tell. I remember working in the central inlier and had to go into the Ballards River. Now, the Ballards River is what they call Milk River. I don't know if anybody here from Clarendon, but there are times, and as I speak to you, I'm having goosebumps because I could have lost my life there. There are times the river comes down very white, milky, milky white. Anybody ever hear about that before?
No,
Yes,
sir.
sir. Yes, sir.
Yeah, man. Let me say white, White.
Chalky white.
Yes, man. So now, my field partner and I, we needed to map an exposure that we saw across the Ballards River because we are hearing that we once had a volcanic activity and we saw an exposure that was inconsistent with the geology of the area. So the only thing that we could say is that something came from underground and came up that is showing you the geology of something that is not at the geology as compared to the geology at the surface. Everybody understand what I'm talking about?
Yes, sir. So far.
Right. So we needed to go over there. So of course we had to walk in the river. So we saw people washing and bathing. So we say, we can test the waters because if they're standing here to wash and bathe, it means that we can go across there. I say, all right, fine. Now with my luck, my field partner walked and gone over, and I'm saying, okay, fine. Let me go and look at something from a different vantage point, and we're looking at stuff. Then the days we never have cell phone. You understand? And no, none of you call me old. All right? Thank you. But we never had cell phones where we can just pop out a cell phone in a waterproof case and just snap a picture, zoom in and snap a picture. Those days will work now, but we never had cell phones in time. And as I stepped, I found myself going down. And I shouted out to my field partner, and I just felt, it's as if something was just pulling me down. When I was going down violently, I started making a pull up a nice nose, say, what is the people them in the river saying, no, don't fight it. I said, don't fight what? And of course, no, media grow, media riverbed, no, because, and the people them said, just relax yourself. One man held my hand, and I said, okay. So you mean to me left Kingston, good Kingston, to come, to come lose my life? They said, no, Father, no such a work. They said, no, that's not how your script is written. And when I checked us up, I was in the river in a section where they had quicksand. So I was thinking, and the people them say, no, man, every day we're coming at this, we have to know how to deal with it. Them say, if you fight it, it'll go swallow you. I said, I don't care. Somebody hold up on my foot, never fight. That is our natural reaction. True or false?
True.
Me, what I mean, see something, me feel something, never shark, me I fight that. I am not going to die. Just say, okay, shark, you can have a leg. You can have a toe. No, me I fight him. So when they said to me,
but I'm more concerned about crocodile still.
Straight up. But the truth is, because they were washing and bathing there, I know it was a safe zone. So the truth is, I know that, and it was the honest truth is that you could see the bottom of the river. It wasn't so cloudy. It wasn't milky white at that point in time, right? But when I started fighting, I kind of rake it up and it kind of getting a little cloudy. And they just held on to me. I said, just relax yourself. And they were there talking to me, and they said, just relax yourself, just relax. And relax, and they're pulling me, and they said, just relax yourself, man. Everything's all right. And they're talking to me casually because they don't want me to panic. And then after that, I recognized that I was over the other side. I said, but hold on, them say, you don't even recognize they come out of the quicksand. They say, it's true. And I say, all right, go and go do your schoolwork. I said, go and go do with schoolwork. He said, done for the day. And I just come out all of us and go back to the house. We don't do nothing more for the day. And I just started to reflect, oh my goodness, this was the reality. So I say this to say to you that as environmentalists, you're going to find yourself into areas where, not to put yourself at risk, but you're going to find yourself in areas because you want to get the answer. You're making a prediction and you want to get your answer, because one of the things out of that, we were able to find something we call pyrite, which is fool's gold. And when we went back excitedly, I would send it to our lecturer, I don't know, we found pyrite, we tested it, and it, no, they didn't say pyrite. They said, we found gold, and we tested it, and I said, yeah, there is a section there. But when he came, and we took him to the ear and came, this is not 9 of the quantities, because it is only fool's gold, and you, by the time you purify it, you're not going to have enough. It's going to take too much to do it. I was like, come on, there my name could be down that I discovered something, and but that was it. So you have to make predictions, and then you have to iterate. This word is what I use a lot in mathematics for my calculus students. Iteration. It is something that you're going to be, it's a procedure that you're going to be doing over and over and over and over and over and over again. So what it is when you're doing the iteration, the result that you get from before, you're going to use it into what it is that you're trying to see if you can get, to see what other results will come out of it. And you're going to do that process as many times as is necessary for you to stop. All right, so let's go. So it says the scientific method is used in all sciences, which is what I'm saying. When you hear me making reference to bio, don't think that is a bio class, right? Including chemistry, physics, geology, and psychology. The scientists in the field ask different questions and pertain different tests and perform rather different tests. However, they use the same core approach to find answers that are logical and are supported by evidence. Logical and supported by evidence. So the scientific method, failure to toast. Found a little cheesy one, and I say, you know what, I think this one is nice. It has some little graphics, and I say, let me use it. So we're going to build some intuition for the scientific method by applying its steps in a practical problem from everyday life. Now, let me give you a real life example. I have a friend of mine, very good friend of mine, a lawyer, lives in Canada. But where she says she lives in Canada, she says if she takes a hot bottle of Pepsi, and she works in the United States. So she lives in Canada. She drives across the border every day to and fro. She says if she puts a bottle of Pepsi in the cup holder in the car, by the time she gets over to the United States, it is frozen. So they say, I mean frozen, like rock ice? She says it's frozen. She says it's frozen. It is so cold. And I took a hot bottle of Pepsi, so cold. I was like, okay. I said, that's why God made me born where I born, because that climate definitely was not for me, was not meant for me, and will never, ever be meant for me. So one day she said she got home and her refrigerator not working, the things in the refrigerator spoiled and so forth and so on. And she had to call the technician in because she was ready now to go and purchase a new refrigerator. I said, have you tried everything? She said, oh yeah, I'm just going to buy a new refrigerator. She called the guys to come in to do the stuff. You know what happened? The refrigerator somehow became unplugged. Wasn't plugged in. That's why it wasn't working. And when the technician came and plugged the refrigerator in, the refrigerator started to work. Do you know that he charged her? Charged her.
I was just about to ask that question. I was just about to ask that question.
Yes, man. Charge her money for transportation to get to the place. Charge her for coming and doing his assessment. And I was like, okay, so you could have go put on our money to buy a new fridge. So I'm saying to you, this scenario that I'm presenting, failure to toast, there are several things that we need to do. So you plug in your toaster, no juice now come out of the toaster. Check to see if it is plugged into the wall, and if it's still no juice, you're going to check to see if you may want to unplug it and plug something else that you know is working, maybe a phone charger to see if your phone is charging. If you're not getting any juice out of that, maybe you want to go and look at the breaker because maybe the breaker fly, right? So you can't just say, oh, the toaster not working and just put it on like that, right? So you have to do some of these 6 steps that we're going through. All right, Miss Asia, see you laughing after me, It's all right. So we need to make an observation. So let's suppose that you get 2 slices of bread, put them in a toaster, press down the button, However, your bread does not toast. What are you going to be asking, right? This is your bread. This is your toaster. You plug it into the wall. Nothing happened. Observation. The toaster won't toast. Okay. What is your question? And guess what? It's like Miss Holt, run with her with her food, say she want to plug in her toast and she get her toast right out on time, because she have no time to play. You're going to ask yourself a question: why didn't my bread toast or get toasted, right? So when you check now to see why it is that it's not toasted, you're going to propose a hypothesis. It's a potential answer to the question, one that can somehow be tested. So you are going to say, oh, maybe there is a power cut. You are going to check to see if there is a power cut. If you can verify that there is no power cut, then you're going to ask yourself another question. Toaster now work. Or the socket not working. Let me go and plug something else in to see if I'm getting it. So you're doing a series of tests. And if everything else that comes out that works, you can maybe conclude to say, students, please do not follow Miss Holt unless that fork has a rubber handle, all right? Because you shall just fry yourself, all right? So why my toaster is not working? Then you're going to say, for example, our hypothesis in this case could be to get the toast that the toaster didn't toast because the electricity, outlet is broken. Okay, maybe the outlet is broken. This is my hypothesis. Maybe the outlet is broken. All right. So remember, let me just remind you. So I've asked myself a question. I'm now forming a hypothesis, which is a guess. Then I'm testing my hypothesis. All right. So maybe the outlet is broken. All right. So the hypothesis is that, maybe the outlet is broken. The hypothesis is not necessarily the right explanation. Instead, it is a possible explanation that we can test to see if it's likely correct, or if we need to make a new hypothesis. So just as I said before, you can check to see if the outlet is broken. Not by sticking a fork in it, but by plugging in something else that is operable. And if it works, you can say, okay, my hypothesis is false. All right. So you're then going to be making a prediction. What is your prediction? It's an outcome we'd expect to see if the hypothesis is correct. In this case, we might predict that if the electrical outlet is broken, then plugging a toaster into a different outlet should fix the problem. So if when you plug your phone charger in it, and then you plug your phone to the charger and no juice is coming from it, then you're going to say, okay, fine, let me find another outlet. And you find another outlet, then you can recognize that this outlet is broken. All right. So this is my prediction. So I'm going to use a different outlet, right? So I'm going to test my prediction now. What's that prediction, sir? To test the hypothesis, we need to make an observation or perform an experiment associated with the prediction. For instance, in this case, we would plug the toaster into a different outlet to see if it toasts. Duh, that's exactly what we said we're going to do. Fine. If the toaster does not toast, then the hypothesis is supported. Is supported is likely correct. If the toaster didn't toast, then the hypothesis is not supported, it's likely wrong. It means we'll have to go find another hypothesis. All right. So the result may be that it contradicts my hypothesis. The result then is that we need to look at another hypothesis to see what is going to possibly happen. So in doing that, we can test several different hypotheses. And if you run out of hypotheses, then you can say to the plan, I just cannot be bothered. All right. I'm going to replace this stuff because all the hypotheses that you tested did not work. And then now you're going to iterate. No, your iteration is the last step of the scientific approach, and it's to reflect on your own results and use them to guide your next step, right? And you would have gone through the whole iteration process just to make sure that what it is that you would have done would make sure that things are happening. It says basically what is actually wrong with the outlet. Right panel, in the case of the hypothesis supported, maybe there is a broken wire in the toaster, right? So at that point in time, or maybe you use the toaster a long time you have the toaster, and piece of the wire just get fried out. So your hypothesis is that I will just have to replace my toaster because all the sockets work, I unplug the toaster and everything else works, but the toaster is just not coming up. So your conclusion is that your toaster is inoperable. Now, this sort of approach,
Sure.
we are going. Yes, sir. Go ahead.
Sir, I'll know when I hear you say anything about the toaster plug.
No. Absolutely, then test everything. It could be that when you have some the same thing you said, Asia, the plug. When you have your cell phone, I don't know. I think they make the chargers like that so that you can continue to buy chargers. Me and cell phone chargers don't work. It's like every other day I have to change a charger because the tip of it, because you keep bending it, the continuous bending causes the wire inside of it to break. And then now you're going to have a short, so you have to catch up the cell phone at a particular point. So it is that connectivity takes place right there. So, and if you move it from there so it don't charge, I can't be bothered with the other than drama. So yeah, you're right. You're very right. It could very much.
Earphones as well.
And the earphones too, yes, sir, that's true. So and you know what is also true? Your, we call it, your computer charger, right? Because you keep wrapping the cord. Somebody said to me that I am not supposed to be wrapping the cord because every time I wrap the cord like that, the cord will get disconnected. You're supposed to be folding it. I said, but if you fold it under the same thing, they said, no, fold the cord. I said, okay, fine, I'll go ahead and fold it. But you're right. So nothing could be wrong with the inside of the toaster. It could be the plug head that needs to be changed. And once you change the plug head, you're good to go. Right? So you're correct. So remember, you no need to find your hypotheses. You no need to test your hypothesis. And then you're going to come up with your conclusion. So your conclusion would be the fix for this thing. Somebody else may come up with another conclusion. And that other person's conclusion is also plausible. Right? So for example, you go out into the field and you found quartz, Quartz, mineral. You found quartz. But the quartz that you found was a high-grade one, not the Sensimania, it was a high-grade quartz. And kill you dead is diamond. Kill you dead is diamond because it refracts and it does everything that you think that a diamond would do. I said, no, man, this is diamond. And then you are going to create some hypotheses. Okay, fine. If I were to use a little dilute acid, will there be a reaction?
So you're gone too far, man.
Okay, what should I do?
The first test should I do the coin test to see if it's scratch.
I could do that also. So you see what I'm saying? So you are taking a different route to come to a conclusion. But whichever route you take, the conclusion should be the same. I don't know if you see where I'm going. Because you are using the coin test to see if it scratches. And once it scratches up, say, right, so this thing is authentic, But I may go to another route because you see the truth of the matter is, I may not have any coin in the field, but I'm working with my dilute acid. So it is that I can go ahead and test. So I'm saying the point that the scientific method is that you're doing something scientific. Your scientific approach is by using the coin. My scientific approach is so there's nothing that is prescriptive about it. But, however, your scientific approach must be plausible and follow the steps. So when you use a coin, that can't be the only test. You have to confirm, because you have to do different tests to confirm that here the plan. This is not diamond, it is quartz. All right? So yes, you are correct. I'm not going to tell that you're not correct. You are correct. And somebody else may say, sir, it so happened that I have a magnifying glass in the field. So I can look at it and I can look at the fracture in the quartz and I can tell you that this is quartz and not diamond because it did not reflect any light. And okay, cool. So we're using 3 different approaches, but the conclusion will be the same because the truth of the matter is it's not diamond, it is quartz. Am I making any sense?
Yes, sir.
Yes, sir.
All right, good job. So that's what the scientific approach is. So you won't find, okay, so it says if the hypothesis was supported, we might do additional tests to confirm it or revise it to be more specific. For instance, we may investigate why the outlet is broken. If the hypothesis was not supported, we would come up with a new hypothesis, for instance, and so forth and so on. So this is all that we have discussed. All right, and I tell you where my source of the stuff. All right, so it is what it is. As I said before, your scientific approach will have to follow a particular a particular stance. You know, we have 6 different things that we do. We have to, you know, ask a question. We have to see what is happening here. We have to do the stuff. We have to perform several different things in order to confirm our steps. I mean, or action. Because we can't just say, the man Usain Bolt ran 9.69. That's the fastest time he can go. No, you have to perform. You have to iterate. You have to perform it several different times. And then you recognize that, you know, his best was 9.58. His best was 9.58. Could I ask better of him? Maybe, but he just didn't produce it when the time became necessary. It's just like some students. Some students are just naturally A students. They do their work and they're A's. Some students are students who are, you know, B students. No matter how them study, they're still going to get a B. All right. So this is just how it is. Will they pass the exam? Yes. The end result is that they'll pass, but you'll get, some will get an A, some will get an A plus, some will get a C minus. All right. And that's what it is. So I would have gone through the scientific approach. Let me hear your questions now. Are you understanding? Do you have any? And I love the idea that sir never check the plug. And I hear that sir use a coin. And I hear sir stick a fork in it. I like the contributions to the class. But is there anything else as it relates to the scientific method before I move into the issues of geology as a discipline? You remember, I must stop the teacher now.
So I'm good.
You're good. Nice, nice. What about the rest of you though?
Sir, just to confirm, since or even though the hypothesis is like an educated guess, it must always be right.
It don't have to be. Your hypothesis can be wrong.
So what you said, each time it's wrong, I have to redo it.
Absolutely. So each time you guess, wait, because you're right, it's an educated guess. So when you guess and you do your hypothesis and you prove that that hypothesis does not work, you have to try something else. Put it this way. When you're not feeling well, and nowadays across the world, when you say not feeling well, the first thing them say is what?
COVID.
COVID. You may just have a headache and you're not feeling well enough. Sir, a COVID you have? It's like, okay, because COVID is just there. All right. But what will now happen is when you go to a doctor, you sit in front of the doctor can't look on, I mean, whether or not the doctor is an internist, the doctor cannot see exactly what is happening inside of you. The doctor has to go through the whole step. So tell me, how was your day? What have you been doing? Since you got the first bouts of headache, so while the doctor is talking to you, the doctor is looking at you because the doctor is making an observation, right? You know, doc, my chest hurting me. Okay, this could maybe mean that you're having a heart attack or you're having a stroke. The doctor is going to have a conversation with you because the doctor is watching your mouth movement, because they're seeing that when it is that you are going to be having a stroke, your tongue gets heavy, there's a slight paralysis of the face, you mouth twist. So they are observing that. So they have their little cues as to what to look at, right? And the doctor may say, okay, here's the plan. My first hypothesis, which is that you're having an onslaught of a stroke, is not supported by that stuff. But then again, no, why is it that you're having chest pain? All right, you are going to order for you to do a cardiac echogram because they want to hear how the heart is at. Because I'm making an observation, but I have an initial hypothesis. I now want to test the hypothesis. You call the lab tech to come to do the cardiac echogram. Do the cardiac echogram, it comes back normal. Crap. All right. Thank you, Lord. It's not the onslaught of a stroke. All right. And go back into the textbook now. What could this be? So let me ask you, do you have a fever with it? Yes. What was the highest temperature? Is what is happening? So whichever field that you're in, the doctor is making an observation, then the doctors test the hypothesis, Asia. Test the hypothesis, you recognize that hypothesis does not work. You go back to asking more questions. And the doctor may say, but what is happening? Are you feeling any pain anywhere else? And the doctor said, no. He said, all right, here the plan. In the meantime, I'm going to draw some blood and we're going to do some
blood culture work. And we're going to do some general culture so we can see exactly what is happening. So while the doctor is still observing you, the lab tech is actually doing some blood work to see what is happening there. The doctor is then going to make another hypothesis. Okay, it could mean that you're having kidney stone or gallstone. Then the doctor may come and say, when you urinate, are you seeing any blood? No, doc, but I'm just having some serious pain and this is the general area it's coming from. Okay, no problem. Can you go and give me a urine sample? Because the doctor is trying to figure out what is happening. The doctor now has another hypothesis. So the doctor is going to say to the lab tech, go and test the urine. And specifically, I want you to test the urine for blood. You may not see blood with your naked eye, but they can use chemicals to find out if there's even one droplet of blood in your urine. It comes back, yes, doc, there is blood in the urine. Ha ha! So something is happening in the kidney, right? And the doctor may say, all right, now it is that I find a hypothesis that works so far because I was making a guess that there is blood in the urine. I am now going to be ordering you to go and do a CT scan of the kidneys. When you do the CT scan of the kidneys, you may or may not see anything. But say, for example, you see something, okay, fine. I'm sorry, sir, but you have a kidney stone. And the doctor may say, what I'm going to order for you to do is to drink a lot of fluids. You need to flush the kidneys so it is that you can pass the stone. That's the story, don't you know? Because you find out exactly what it is. That's the story, they're done. You don't need to do nothing more because you test your prediction from the urine, the blood in the urine, you catch that, you're done. But what if it came back negative? The doctor have to go back again and look. And which is why some people say, you'll hear some people say, boy, you know, much time ago, doctor can't find out what happened to me because all the hypotheses that the doctors were testing just now work. Am I clear? I don't know. I just speak out something out of the back a while ago.
Yes, sir.
Yes, sir.
Yeah, man.
Yes, sir.
Yeah, man. All right, good. All right. So as I said before, the scientific method can be used right across disciplines. Right across disciplines, right? I use it a lot. Okay, so I said something to a student, and this is a real situation. One day, I won't tell you the juicy details of it, but one day I said to one of my students, why is it that you come to class so late? And I recognize that you have been late for the longest, for the last couple of weeks. And you are somebody who normally come to class early. And the student responded to me in a tone that normally, me fly off the cage. No man, normally me fly off long time and put the student in the student's place. But this time around, I said to myself, no man, the student never ever responded to me like that. What is happening? So I pretended as if I didn't hear. And when the class ended, I said, you know, we need to talk. Because it's really unnice for the teacher to be talking to you and you just fly up on the teacher like that. What is happening? The student just started to cry. I said, okay, you cannot move away no assertion because you just asked a question, you have to sit around to find out what is happening. And the long and short is that, you know, she was on her way to school a couple of weeks ago. She went into a taxi. They took her away and abused her. And that's all I will say. You can figure out the rest on your own. And it was very troublesome for the student. No, me never did know that. And then I said, student, you want to get help? Student said, sir, I'm fine. I will just deal with it. And I said, oh my goodness. And I felt helpless, right? So sometimes, you know, you ask a question, you make an observation, the student is coming late. I ask a question, why is it that you're coming to class late? And I'm forming a hypothesis in my headspace. You're not waking up early enough. But that hypothesis was wrong. And then when the student spoke about the stuff, it closed off the situation because I don't need to guess anymore because I know the true story on it. I'll just leave it there. All right? So if you can try this in your regular walks of life, tell me if it works or it won't work. Next class, you come back and talk to me. All right? But at this point in time, I must move now. If there are no other questions to some issues that we have, and I'm just going to look at one. And I'm doing one because I want you to be able to look at the other. All right. I'm going to project something. I need to visit another class to help a lecturer sort something out. I'm going to project something on screen. You may have to zoom in to hold on 1 minute. Sir, can you send me a WhatsApp of your Zoom class, please? I can just click on it. Thank you. So I'm going to hang you up now. Just send me a WhatsApp of your Zoom class, and I'll click on it and join the class in another 2 minutes. All right? All right, cool. Thanks. Sorry about that. So I just need to visit a class to just sort out an issue. So I'm going to project something here for you. And when I project it, I'm just going to give you, all right, let me see if I can just copy it into this document. And I want you to read through. Whether or not you're understanding, I want you to read through it, and then we'll come back and have a conversation on the matter. Yes. All right, so all right, it's there. Let me just, well, you're seeing my screen, but it's a little, fine. Let me put it at 1.5. Right, better. I'm going to put it as a reading view. Oh dear. Can you zoom in and see that, or go back to the other view?
Sir, go back to the other one. It was much better before.
Okay, all right, no problem. All right. The WhatsApp for the lecture came in just now. All right. I'm listening. I'm gonna mute. I'm listening. When you want me to, oh Lord. How do I do this? I don't want to send this to you just yet because I need to summarize before I send off. I just took this verbatim from the net. But I need to have a conversation with you on it. Just let me know when you want to move to the other page, and I can do that. All right, I'm going to mute.
I finished, sir. Finish. Finish. I finish here, sir.
All right, give me 2 seconds. I'm coming back to you. Okay, all right, sorry about that. All right, so can I safely assume that we read through the document? What did we get from it? Somebody talk to me.
That time is important in geology.
How important do you think it is?
I think it's very important, especially being that the physical how I should put it now, some of the physical processes that occurred a long time ago, it's difficult for us to comprehend the duration of the time.
Trust me, if you're near me, would I get Tigger's money? No, true. Would I get Tigger's money? Yeah, man. Very nice. Very nice. You know, one of the things that got me scared when I just went into a class, 65 million years ago, we had dinosaurs. 65 million years ago. We live so long, we have 65 million years already. And I used to just question it. So for me, what gave me some problems was time. And I have a nice little activity so that it can put things into perspective for you, because you know, I am one of those real teachers. If they have one problem with something, I am not going to let my students have the same problem. I'm going to tell you, time for me was one of the major issues, because I'm saying, how do you know that we had those dinosaurs living 65 million years ago? Show me the evidence. And then another man, they may say, okay, fine, we have fossils. We have fossils that are the evidence. But how you know so that, okay, when a tree dies, it does not fossilize immediately. We can do radiometric dating, which is another time-sensitive feature to tell you how long this will take in order to fossilize. And archaeology also links very well with geology. All right, so this is what I'm saying. This discipline will come like salt in everybody business, or I should say everybody's in our business. All right, so you have to be able to put things into perspective. So when they said to me that 65 million years ago we had dinosaurs running up and down, I was like, okay. And then when they said that 100 years ago we had a pandemic, the SARS virus, I was like, okay, yeah, we can understand that, you know. Matter of fact, let me ask you, why do you think that I can say to you that I can understand that 100 years ago we also had a pandemic similar to what we have as COVID in COVID now? Tell me why you think I said I could understand that.
Because it wasn't that long ago.
Okay, it wasn't that long ago. All right, explain a little bit more than that. You're correct, but why do you think so? It wasn't that long ago, yeah? And talk to me.
So, I mean, before, like, as you said, 65 million years ago, there were dinosaurs, things we didn't see, so it would be hard to believe.
But Asia, I like what you said a while ago, things that we didn't see, but I wasn't there 100 years ago when the other pandemic broke out. So talk to me, Asia. I'm trying to squeeze it out of you. Come, sweetie, talk to me.
I guess we have an idea of what a pandemic will look like since we are in one right now.
No, but people now are comparing the one that happened 100 years ago to know how are they able to make that comparison. You're right. You have it, talk to me. So when I listen to newscasts, I hear people talk about yes and that and making comparisons and so forth and so on. How is it that we can accept those comparisons as true stuff? Yes, I hear you say that it's not because it wasn't so long ago, but there's something else that I want you to think about. Why is that we are able to do this? Tell me, talk to me.
The evidence that was left behind.
The evidence that was left behind. Okay, who is leaving the evidence?
Like history books and video footage, and not video footage, like newspaper clippings and so on, and medical
documentary. Okay, fine. We're getting warmer, I want to hear from the rest of you. I thank you for raising that, Asia. And I thank you to others. Yes, Mikey, I hear you coming in. I thank you, but there's something else that I'm holding on to, and I want somebody to say, "Come on, think." What are you thinking, Cap?
Their oral tradition.
Oral tradition. What is that?
When different generations pass on the information.
Okay, so talk to me. So you're supporting Asia just now. So how you know? Come, if I say it, let me see how I put it. So
the signs, the experiences.
But how you know the experiences? So you're saying the same thing as Rodriguez, Henriquez. How you saying this? What is it? What experience are you talking about? Talk to me, man. I don't want to tell you. I want you to think about it. You're all correct,
Now the population went through.
The population? Okay, what about the population? Because you're on the right track again.
It was declined because of all of this.
It declined? Okay, but all right, okay. If I look at decline in that positive sense. Go ahead, Mikey.
Is it that you are able to get that information from persons who have experienced that?
Thank you very much. Thank you very much. So Asia, this is what I wanted to get to, because you do have people who lived through the pandemic 100 years ago. Talk truth.
Yes, sir.
Yeah, man. Yeah. So for me, it was much easier. And guess what? And even though they may say that, I was 10 years old or I was 5 years old when this happened, and somebody and Rodriguez talk about oral tradition. I was 5 years old and I lost my granny and my grandpa because of that, and my mother was able to say this. So you living at the tail end of the pandemic that took place 100 years ago, and then you come into the 2000s and experience this one, you still have had some levels of experience or experiences. Anybody see where I'm going?
Yes, sir.
Yeah, man. So it is easy for me to gravitate to what somebody is saying now, because the two eras, people have lived through them and can speak about the experience. And in speaking about the experience, you can say, yes, we know somebody, a live person who is talking to us about it. They may not even fully experience it, but this oral tradition that Rodriguez is talking about is one that you're passing on the tradition. But hear my challenge now. Who did live 65 million years ago to pass on that tradition to me? I don't know if anybody see the point I'm making.
Crocodiles.
And trust me, I am not going to be having a conversation with any of those creatures, right? I run in the opposite direction when I do see one. All right. So this is why the issue of time becomes very, very, very important, right? I don't know how many of you got an opportunity to read through the document, but it says in some things, it's one thing to know the facts about geological time, how long it is, how we measure it, how we divide it up, what and when we can call a various period or epoch. We don't know. We don't know how it is that we are going to be calling. We talk about different times, the Cretaceous time, and we don't know. We have no clue. But it is quite another to really understand geological time. It's a serious issue. It's a serious issue. The problem is that our lives are short and our memories are even shorter. Real talk. Our experiences span only a few decades, so we really don't have a way of knowing what 11,700 years mean. We don't. So when the man tell me about 65 million years ago, what the difference are you talking about? So, and difference is a good word here. So I am in a class and I'm hearing my paleontologist, my paleontology lecturer is talking about, talking about dinosaurs 65 million years ago. And I'm sitting and I'm saying to myself, 65 million years ago? So how them get it? The lecture moved gone long time, Finish one chapter and start the next chapter, Finish that chapter and read the third chapter, where Sir Shand is? 65 million years ago. And I got stuck right there. And when the teacher moved on, and I still got stuck, and at the end of the class, I was still right there. I would have missed everything else that he would have taught. So I had to go back now and look at the stuff. So I'm saying to you, I don't want you to be there. I want you to just understand what it means. And I'm going to show you something, a little exercise, hopefully, that it will help to put things into perspective. What's more, it's hard for us to understand how 11,700 years differ from 65.5 MA. What is MA?
Millions.
Million years, yeah. Or even 1.8 GA. What is GA?
Billion.
Billion years. Thank you very Miss Reed. So I want to know, how does 11,700 years differ from 65.5 million years or 1.8 billion years? No, it is something that is very serious. Because if it is that we're going to be mapping the start of time geologically, we have to go back into these time frames. We need to know how to calculate these time frames. So it is that we can have an understanding. It is not that we can't comprehend what the numbers mean. We can all get that figured out with a bit of practice. But even if we don't know the numerical meaning of 65.5 million years, we can't really appreciate how long ago it was. That was the issue that I had. Serious issue. You may be wondering why it is so important to really understand geological time. True. But there are some very good reasons. One is so that we can fully understand how geological processes that seem impossible, slow, can produce anything of consequence. For example, we are familiar with some of the concepts of driving from one major city to another, a journey of several hours of about 100 kilometers per hour. Continents move towards each other at rates of a fraction of a millimeter per day, or something in the order of 0.00 kilometers per hour. And yet, it is impossible. This is an impossible slow rate. Try walking at that speed. So they can move thousands of kilometers, right? So sediments typically accumulate even at a slower rate. Anybody ever wonder how a sandstone is formed? We know how it is formed. It is a classification of these sand particles, because when we get into the whole chemistry of it, it stays there, and you wonder, some people will say, then sir, how it has such a nice smooth surface? It's a continuous beating of the water that shapes the stones and the whole stuff. And then we have these aquatic creatures that help to do the stuff. Their urine from the uric acid contains, and the decaying of their bodies contain carbon, and these carbon will form that sort of binding cement to it. And this is how a lot of these minerals are produced, and a lot of these stones are produced. Then sir, we have these wonderful colors. Aha! Over time, it's not 1 year or 2 years, it's many, many, many years. Many years, right? It says, but they still are thick enough to be thrust up in a monumental mountain and carved into breathtaking canyons. Right? I mean, when you look at all these stuff, right? It says another reason that for survival of this planet, we need to understand the issues like extinction. Oh, that's what you're talking about with the dinosaurs, sir, with the 65 million years ago. Yeah. And then you know what happens? It's because I read about that 65 million years ago we had those dinosaurs. When I watch and see the African elephants, when they're saying that they are going to go into extinction, I can understand what extinction means. So what they have to do is to move these African elephants out of Africa into places like maybe Canada or the United States or some other countries. So it is known that they can go and they can breed them, right? So what it is that they're going to do is like inverted fertilization. So they are going to actually, remove some eggs from the female and cause it to be able to fertilize. So it is that they can impregnate the female. So at least they did that recently, as a matter of fact, with some pandas, right? The pandas were going into extinction and they said, no, we cannot have these animals going to extinction. So they isolated those pandas. They isolated the pandas and the pandas were able to breed, and they have, I mean, it was, and if you don't believe me, Google it. It was a joyous moment that they had celebration when they had a birth, and they didn't even have, I don't think the panda had natural birth because they didn't want anything happen to that, the baby panda. So what they did, cesarean section. Cesarean section, so it is that they could birth the panda and they have it and then they start the process again. So now those new little babies, as soon as they get to a particular age, they're going to start to reproduce them, right? So what they did when those were birthed, they took the pandas to their native land. It happens because we don't want them to be extinct. All right, give me half a second. One minute, guys. All right. So let me help you to prepare your final paper. A possible question on your exam paper could be, there are a few issues in geology. Discuss 2 or 3 of the issues that geologists face today, for argument's sake. A simple question, maybe about, if there's 2 issues, it could be about a 10 marker, right? 5 marks for each issue, but of course, you know, you have to get into some serious stuff. Talk about different examples, you know, why is that this becomes an issue. So if you want to use time as one of your issues, is time. It could be scale, it could be something else. But they may ask you to discuss, and they know geologically, you know, you will have to talk about it, how this affects and, you know, affects you. All right, so I was saying to you that another reason is for the survival of this planet, we need to understand the issues like extinction. It's very important, very, 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 very important, right? Some people don't understand geological time. We are quick to say that climate has changed in the past, and what is happening now is no different. You know, you know, leave that alone until at another time, because it's going to come up. Right, leave that one alone. I was going to talk about the Eocene period, 50 million years ago, but I'm going to leave that because I want to jump into something else, and time is running. It says that, and I'm going to do this in class today, you know, don't get me wrong, I'm going to do it in class today, but I'm going to show you something. We're going to do something, a little activity that will bring this out. So one way to wrap up your mind around geological time is to put it into perspective of a single year, because we all know how long it is from one birthday to the next. All right? We know how long it is from one birthday to the next. It says at that rate, each hour of the year is equivalent to approximately 500,000 years. What is it, sir? Each hour of the year is equivalent to approximately 500,000 years. And each day is equivalent to 12.5 million years. Did anybody hear what I said a while ago?
Yes, sir.
All right. So let's, you know, one of my passion, I was the only person in my year that studied this and mathematics together. And I had a clash every single day of the week, because guess what? When I went to my department, they said, we've never come across a student who is doing math and geology. Sorry, we can't facilitate you as just one student. I went over to math and I said, I'm sorry, we've never had a student who come up. So I was one of those few students who went and did this. So I say this to say to you that I have an appreciation of numbers, a good appreciation of numbers. And I'm going to read that statement again. Each day is equivalent to 12.5 million years. It's very important, very significant, because at least that gives us now a reference point for which to back calculate what is happening. So when they come to about 65 million years ago, and they give you some times that you're saying, but I wasn't living there, they have approximated some time frames. So it is that we can put things into perspective. Not until that was done for me before I was able to have an understanding and an appreciation of what this life and, you know, is all about. If all of geological time is compressed down to a single year, Earth formed on January 1, and the first life forms evolved in late March, is approximately that little sign, that little squiggly sign in front of this 3,500 is approximately 3,500 million years. The first, remember, it says, if all of geological time is compressed down to a single year, Earth formed on January 1. And the first life forms evolved in late March, which is approximately 3,500 million years. The first life forms appeared on November 13th, is about 600 million years. Plants appeared on landform November 24th, and amphibians on December 3. Reptiles evolved and amphibians during the first week of December, and dinosaurs, early mammals, so forth and so on. And all of that 160 million years. Then we can understand how them get this stuff now, because all of that now puts things for me into serious perspective. My question to you, are you getting a better understanding of time in geology now? Are you seeing anything just from this little document? Remember, if you read more about it, I am only whetting your appetite. Are you seeing anything so far about time?
Sir, so are you saying that based on the geologists, they use a 24-hour day in which to compress features that were formed over different epochs? Oh, that's good.
Yes, sir. You got that one correct. You got that one correct. Where am I? You got that one correct. I want to do a little activity with you. I want to do a little activity with you. All right. The activity that I want to do with you is this. I want you to look at your birth dates. I want you to look at your birth dates. You don't necessarily need to tell us when is your birth date. So, for example, you're born. I think the example that they use here was All Fools Day, April 1. All Fools Day, April 1. How many days starting January 1 to April 1 do we have in between? How many days between January 1 and April 1? Find a calendar and check it quick time. I will tell you which one is correct. Which one of you is correct? I step in away one more second. I soon come. Check it for me in the meantime.
Leap year or no leap year?
It doesn't matter. I'll come.
$90 days without the leap year and 91 days with a leap year.
All right, so January 1 to April 1, how many days?
90 days.
Very good. 90 days. 90 days, right? So this is what I want you to do for me now. So I gave you a reference point because I wanted.
91 leap year.
All right, you get 91. We're gonna use the non-leap year then. Or it doesn't matter, whichever one you want to use. This is actually it doesn't really matter. All right. So we got 90. So you know how to do the calculation. There are some silent ones in here that we need to get to the point of start speaking so we can have fulsome participation. So it's 90 days. Now what I want each of you to do is to count from January 1 to your birth date. I can't tell if you're right or wrong, because I don't know your birth date. So that's why I gave you a reference point now, the January to April 1, so you can tell me so I know that you know what is happening. Because when I did it, I got 90. So I want you to find your birth date from January 1 to your birth date. And when you get that number, just say, sir, I have the number. And I want you to write it down. And I'm doing the exercise myself too. And God forbid if you're born December, it's only for things you have to go add up. So let me just grab calculator. Okay. Anybody get it yet? I have mine now.
Yes, sir.
Yes, sir.
All right, nice. So write that. Okay, write on mine. Anybody want to share quickly what number they got?
160.
Okay.
307.
Boy, you sound like you're born in
178.
178?
Yes, sir.
The 307, they sound like you're born in September. Anyhow, go again. Anybody else?
194.
194. Anybody else? Wait, say what I got? 378 or 278? Rodriguez, wait, say.
307.
Oh, because I'm saying in my mind, I just said 378. After not so much this another year. All right, and cool. 307. All right. Kylo, what say you?
178.
178. Karel, talk to me now. I want to hear from everybody, man. I want this to be interactive enough. Ven, what say you?
160.
160. All right. Karel, you never born. Come talk to teacher. I don't chat with you.
Sir, me never do it.
Yeah, man. All right. Okay, so let me project what I want you to do for me. I'm going to project what I want you to do for your teacher. Oh Lord, but can I get no? I may have to do it. All right, I may have to. It's all right, I click on it and do that for you. I'm going to send you the stuff nonetheless. All right. So now that you have it, all right. So this is what Sir wants you to do. The number that you get from the number of days from January 1. What I want you to do is to divide that number by 365. So Kylo got 178. So Kylo can put 178 over 365. Go ahead for me, please. Somebody got 307. Rodriguez got 307. So he's going to say 307 divided by 365. Abid?
Yes, sir.
Mm-hmm. What about the rest?
Yes,
So
sir.
I got 47 to 3.
You got 47 to no man, you can't get 47.
In point, 0.72.
Oh, you're friendly me.
So
You're
there's
friendly
any
me.
specific decimal place we're supposed to run up?
You can let us use 4 decimal places. Let us use 4 decimal places. Time is good, so I have to do this. Yes, Papa, go ahead.
0.4876.
That's perfectly fine. That's perfectly fine. All right. So it's when you get that, and everybody should get a decimal. Everybody should get a decimal. All right? Because it can't, your birthday must fall within 365 days. All right. Now, that number you're going to multiply it by 4570. 4570. You're multiplying that number by 4570.
2,228.6575.
Mm-hmm. You see that number? It's going to represent million years from the start of time. That is million years from the start of time. So you see from time started, that 2,000 something that you get is 2,000 million years from the start of time. Anybody else get a number?
3,843.
For the birthday, I wrote November, December.
Yeah, November.
Me at 3305.
All right, good. Now, you see that number? I want you to subtract that number now from 4,570. That's it, that number that you just quoted a while ago, Mikey. Subtract that number from 4,570. The same 4,570 that we multiplied. Subtract that number from it, please.
Sir, it's coming a negative and a negative. Well, 1265. No, 1265. 1264.
Right. So it's supposed to be 4570 minus whatever number you got. I ain't got 1264? No, man, you sure?
Yeah.
2,566.71.
2005. Yeah, so like that sounds more like it, man. Benika. Come, Mikey. Look again.
Sir, may I get a negative number?
Remember, you know, you're going to say 4,570 minus the number that you got when you did the multiplication. So the bigger number is supposed to be in front. You can't get a small, you can't get a negative number. It means that it never exists. It never did born.
727.
You get 727?
Yeah.
All right, then fine. Mikey, you said that you got 3,000 something, Mikey? What was your number, Mikey? 3,000 and something?
3008.
3,008.
3,308, sorry.
3,308. I ain't getting 1,262?
No, 1,002. Yeah, 1,262. Yep, correct.
All right, so that's 1,262 million years is your geological date. That is going to be your geological date. That is your geological date, Mikey. 1,262 million years. Yes, sir. That's your geological date. All right. Let me see if I can put this in now.
That means what exactly is a geological date? Because I wasn't.
All right, never mind. We're going to come to that, but I want you to look at this. I'm going to come to that. I hope I have enough time. But we're going to come back to this again. So how much? What was your date again, Mikey?
The 3,308.
All right, I'm going to send you this. I don't want to do this here. I'm not going to do this here. I'm not going to do this because I just recognize it is asking for the date entered in months here. I don't want to broadcast your birth dates like that. So I'm going to send this to you and I'm going to ask you to do it for me. Stop share, new share. Forgive me. I'm not going to broadcast that one. I'll show you something else, however. I will send you the document so it is that you can put in the information and you can have a look at it yourself to see what is happening. All right, I'm trying to bring up something else, but it's just, come on, let me just put that here. Oh, man. All right, let me see if I can. Oh. Half a second here. System is not responding. Just half a second. All right. New share. All right. So I'll end the class run about this. Okay, Mikey, what you got, Mikey, for your thing again? 1,262. 1,262 is closer to 1,300, right? So, Mikey, that would be you. Which is about 1,300 million years. Mikey, that's what you got, right?
Yes, sir. Yes, sir.
All right. So this is representing you. So they claim. And it is speaking about self-sufficient algae, compatible home, rapid transport, sunlight. And I'm going to send this to you so you can play around with it to see what is happening, right? The cross-species celebrate success, permanent features, the bacteria transform into new. All right, so this is what you're saying is happening at that time, right? Geologically, this is what is happening at that time. Can somebody else give me a number that they got?
3,843.
3,843 is closer to 3,900. Let me see if they have a 3,900. They have a 3,003, 3,004, 3,900. So 3,900. See here, so up here. If you look at, are you seeing my screen?
Yes, yes, sir.
Right. So 3,900 MYAs million years. We will continue to make backwards as we develop new tools for observation and analysis. Recent discoveries suggested that life on Earth may originate as early as 3,850 million years, even as the planet sustains heavy bombardment from meteorites and other incoming bodies. All right. So this is what Archie and Earthscape. This is what you're saying is happening. Life takes tenacious hold. This is what is happening within your time frame at the 3,900 million years. All right. Anybody else? One other person.
2,566.
2,566 is about 2,600. 2,600. Wow. So 2,600 million years surfacing. Larger, thicker, stronger continents emerge as Earth cools. Closing the period of major crust formation, the continents grow as and stabilize shallow. Okay, so this is what happened 2,600 million years ago. So pretty much you were around about this time. You know, geologically, this is a time, your birth date, time of your birth. This is what was happening at your point in time. Oh crap, I forget to do that last calculation. Anybody got, give me one other. I know it's 701. Give me one other, quickly.
Nobody? 2,428.
2,428 is 2,400. When you round off, 2,400. Wow, look at this. Nice. So 2,400 million years. Massive amounts of oxygen waste, no surplus bodies in the Earth's atmosphere. Oxygen was reacted immediately with hydrogen, carbon, and iron from oxides such as water, calcium carbonate, limestone, hematite, and magnetite. These are nice minerals. These are what it is that you're seeing. The worldwide age of the BIF content. Ah. Wow.
So Asia basically.
Asia, wow. Are you brightly colored Asia? Are you for 600 million years sediments of the ultra? All right. So what I'm gonna do, I'm gonna put all of this together. I'm gonna set, because you recognize that the number between your January 1 and your birth date is a constant. Talk truth. Hello.
Yes, sir.
Yeah, man. So once you do this calculation one time, this is exactly what it is saying. So what we're doing here is just, and it's just a nice little activity to get you familiar with time. So time shouldn't really be a factor just now, right? And I'll show you how it is to go about doing the calculation. So you can follow the calculation, so you can see what is happening. So when we speak of 65 million years ago, I can now put things into time frame, because what this is saying is that my birth date is corresponding to Asia's birth date is corresponding to 2,400 from January is corresponding to 2,400 million years, right? And this is what Earth was like at that time, all right? So I trust that tonight's class somewhat excited you, that you really want to go read more and find out more what Sarah talked about, and we'll continue next week. I'll send this off to you so that you can have something to prepare for next class. All right, guys?
Right, sir.
Yes,
Good night,
sir.
sir.
Thanks
Sir,
for
can I
coming.
ask you a question, please?
Go ahead.
Why is business calculus not being offered in the summer?
Oh, why is busy? Oh, how do you pronounce the name? Skylin?
Skylin Blinkum, sir.
Oh, okay, all right. So you're a business calculus student, and because you see that I'm having a class, you decided you can come in and ask me, don't? Say yes.
Yes, sir.
No, all right, cool. All right, so I spoke to them today about it. I wrote an email requesting, are you in your final semester?
Yes, sir. That is why, sir.
Right, and so you're finishing off your associate degree this year, right?
Yes,
This summer.
sir.
Yeah,
Yes,
so
sir.
I sent an email and to the School of Business and the timetabling officer requesting that they put business calculus on for this semester, because I have a few students. Now that I can put you down, Skylin, on the list of a few students who are completing their associate degree this year. So I asked them to ensure that business calculus is on. So hopefully we will have a class in for next week. I'm going to ask you to, how do I do this now? Send me an email, Skylin, please, because I have the names of the other two students. So I'm putting
Right now, sir.
Right now. You have my email address, right?
Yes, sir.
Come on, just send me an email.
What email address I should use?
School, yes, sir. School email address, so that I can speak to them specifically about it. And I guarantee you that we will have the class going, because if you need to finish your associate degree this year, we can't not have the class running.
Yes, sir. And I believe maybe other students who did it last semester, maybe.
Well, do me a favor, Skylin. I'm going to charge you with the responsibility to speak with those other students who you know and who's supposed to be finishing off their studies this summer here, and put their names in an email and send it off to me, so that when I go to the meeting, we can just make up your nights and tell them why it's supposed to be there. All right, bless up, Papa. Take care. All right, no problem. All right. All the best, guys.